Hello, my name is Vincent Tran, and this is my Physics 2211 Lab 2 Motion of a Falling Object. First and foremost, the purpose of this lab is to observe the motion of an object that is dropped from rest and falls straight down. And in this lab, I use a sponge as my object. I will also create two computational models and compare them to my observations. And for this lab, I predict that the model, which includes the effect of gravity and drag, will be more accurate than the model that includes only gravity. Some key physics principles that we'll be using in this lab is Newton's second law, which states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. Next, we have gravitational force, which is basically the force between any two objects with mass. Next, we have drag force, which is the force opposite to any object in motion. And it is important to note that an object that is falling towards the ground does not have a constant velocity. Therefore, Fnet will not be zero. Here is the tracker video analysis of when I dropped the sponge. As you see in the video, the object was dropped from rest, and as you can see, it hits the ground there. And looking to the right, you can see the position versus time graph over here. As you can see, as time increases, the position slowly decreases. It starts at initial position of 0, and as time increases, it slowly goes down. And here's the observed data that I got from my tracker video analysis. The mass is 0.002 kilograms. The initial position is 0 meters. Initial velocity is 0 meters per second. Observation start time is 0 seconds. Observation end time is 0.767 seconds. And final position is negative 1.458 meters. Here's the GlowScript code that I used. This is for the gravity only model. As you can see, the proportionally constant for the magnitude of the drag force, I set this to 0 because this has no drag force. And here is the calculation loop, which I set the time to 0.767 seconds because that's how long it took for the object to go from rest to the ground. And here are the results. As you can see, the ball shown here is similar to the object shown in the tracker video analysis, which shows the ball going from rest position ending to the ground. And here's the position versus time graph for that. Here's the code for gravity and drag. As you can see, I set b equal to 0.00655. This represents the drag. And I also added arrows to show the drag vector and gravitational force vectors. And for the calculation loop, I added the force of drag equation. And then I also added it to the Fnet equation. And here are the results. As you can see, the blue arrow represents drag, which is going upwards, while the orange arrow represents gravity, pulling downwards. And here's the position versus time graph. As you can see, as time increases, position also decreases, which results in a negative sloping graph. And here's the graphical comparison between the two models and the observed model. And as you can see, the model with gravity and drag is more accurate and closely resembles the observed model compared to the only gravity model, which is shown in red. And some discussion. Examine the velocity versus time predicted by your models with and without drag. Which models, if any, predict a terminal velocity? I'd say that the model on the left, which was gravity and drag, has terminal velocity. As you can see, as time increases, the velocity is slowly flattening out, which shows that it is slowly approaching terminal velocity. Compared to the graph with only gravity, is constant and it will not approach 0. And imagine that the object was initially thrown downward. Would the terminal velocity in this case be the same or different from the case where the same object was initially dropped from rest? I would say that the terminal velocity would be the same because terminal velocity is only affected by the actual weight of the object and gravitational force. and only the initial velocity would change in this case because the object is initially thrown downwards. And that concludes my lab. Thank you for watching, and I hope you have a great day.